Good day, I am Michael Alexis L. Parantar and I am here to discuss measuring distance on a Mercator chart and why longitude is not used when measuring distances on the chart. Measuring distance on a Mercator chart. Introduction. What is chart work? A chart work is a practice done by navigators that involve plotting courses and other navigational process on a chart. Chart work is crucial to passage planning and safe coastal cruising. Accurate chart work is the basis for good navigation. Before going to sea, a course is plotted on a chart noting bearings, distances, and expected times for each leg of the trip. While at sea, position is fixed at regular intervals and the course adjusted when necessary. Instruments for plotting. An increasing number of mariners today rely on automated tools such as GPS for navigation and getting from one point to another. Indeed, a good marine GPS will not only replicate a chart's details, but can aid in determining course, distance, elapsed time, and position. Materials needed when measuring on a Mercator chart. Navigational chart, compass dividers, pencil and eraser, parallel ruler, protractor, triangle, chart plotter, and etc. Parallel ruler. The parallel ruler can also be used as a straight edge when connecting 2 points on a chart. Some parallel rulers, such as the one in the figure, have additional protractor markings around the edges. Parallel or roll plotter. A parallel or roll plotter is an alternative to a parallel ruler. A parallel ruler plotter has a roller that allows the device to be moved across a chart without changing its orientation. Protractor triangle. Protractor triangle is another common tool. In addition to being a straight edge, it can also help find the heading when used in conjunction with a parallel ruler or roll plotter. Dividers. Dividers are used to mark the distance between 2 points on the chart, or to mark points on the chart at which to place a ruler, parallel ruler, or roll plotter. Measuring distance. Distances can be determined using dividers or a ruler, although the former is more commonly employed because it can be used with more precision. The most common way to determine a distance is to set the dividers to the length of the line connecting 2 points. The dividers are then placed against a scale on the chart to find the actual geographic distance. In most cases, problems require determining distances in nautical miles. Remember that a minute of latitude is equal to 1 nautical mile. Thus, the distance of a line on a chart can be determined by holding the dividers up to the latitude vertical scale on the side of the chart. Never use longitude horizontal scale to determine the distance between 2 points. It is worth remembering that the vertical latitude scale on a Mercator chart can be used to measure distance, not the horizontal longitude scale. As an example, suppose you want to measure the distance between 2 points on a chart, in this example between two buoys. First, set the dividers to the 2 points over which to measure the distance. Next, place the dividers against the latitude scale on the chart to find the distance, which is approximately 3.8 nautical miles. If the line connecting the 2 points larger than the span of the dividers, set the dividers to a span representing a no distance. and then count the number of increments of your compass span in order to cover the length of the line. Finding latitude and longitude. The easiest way to determine latitude is to orient the parallel ruler on a horizontal line on the chart, and then walk the parallel ruler until it meets the point of interest and lines up with the chart's horizontal scale. The latitude can be read from the scale. Longitude can be also found in a similar way, except that you line up the parallel ruler along the vertical line on the chart. Figure 2.10 shows an example of this process. In order to find the position of green buoy number 3 on the chart, start by positioning the parallel ruler through the buoy's position in the horizontal line at 54 degrees 35 minutes north, and then walk the ruler to run through the buoy's position and the horizontal scale. Next, position the parallel ruler through the vertical line at 83 degrees 35 minutes and walk the ruler to run through the buoy and the vertical scale. The lines show the position of the buoy to be 54 degrees 35.5 minutes north, 83 degrees 12 minutes west. If the position of interest is further from the edge of the chart than the length, the parallel ruler, you can find the latitude and longitude by employing dividers. Line up the ruler with any vertical or horizontal line on the chart. Move the position to measure and use the dividers to see how far you are from the line. Then use the dividers on the vertical or horizontal scale to find the latitude or longitude, respectively. Remember that charts are always oriented with true north towards the top. When looking at this chart, notice that the minutes on the vertical scale increase going from bottom to the top. This means that this chart is in the north latitudes. Similarly, the minutes along the horizontal scale are increasing from right to left, meaning that the chart is in western longitudes. Plotting a position. Plotting position from latitude and longitude is the opposite of determining those coordinates. In this case, you are given the latitude and longitude. You need to find out where you are on the chart. This is accomplished much like the steps above. Suppose you need to find position 54 degrees 34.5 minutes north, 83 degrees 21.7 minutes west on the chart. Use your parallel ruler to mark a line at the proper line of longitude. The intersection of two lines is your position. Finding a true bearing and compass course. When laying out a course on a chart, it is important to remember that all headings are relative to true north. There are times when you need to account for variation and deviation, such as when you obtain a magnetic heading from a compass or need to determine what compass heading to steer on your vessel, but plotting routes on a chart are always true. This section describes how to find the compass course, knowing an initial point and an intended destination. Another term for this is the intended course. If you know the 2 points and want to find the course between them, this is sometimes referred to as the course made good, which is the actual course you took between the 2 points after accounting for compass variance and deviation, wind, tide, and other factors. As an example, suppose you need to plot your course from latitude 54 degrees 35.5 minutes north, longitude 83 degrees 20.5 minutes west to red buoy number 4, figure 2.12. Find the 2 points and draw a line between them. This is called the track line. Number 2. Line up your parallel ruler and walk it to the compass rose. Number 3. Note that your line will intersect the compass rose in two places. Why longitude is not used when measuring distance on the chart. Longitude scale. Longitude scales are the horizontal lines on a map. These do not measure distance. That is because the distance between these lines can change. Longitudes lines get further apart as you go north. Thank you for watching. That's all.